Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. And in this module we are trying to understand how does the operating system manage the CPU, right? By providing this abstraction of a process. So within the second module, currently we are on the second topic, which is process address space. And as I said, through a series of videos, we are trying to understand how does the memory appear to each process. Every process has its own address space, and this address space helps the process to organize its code and data in the memory in a proper way, right? There are several sections, and we have been talking about these sections. We have studied the code section, the stack section, the remaining two are data and heap section. And in this video, we are going to look at the data section. So let's understand why do we need the data section and what does it contain. And without further ado, let's get started. So let us start the discussion with this slide, right? As you can see here, we have the process, and this is the process address space that is associated with this process, right? Now, we have talked about this, that is in a previous video we have studied what is static versus what is dynamic memory allocation, right? We have studied about these two types of memory allocation, and we said that the heap section is used for dynamic memory allocations, and the data section stores objects which are statically allocated, right? So now let us understand what are the different kinds of objects that are stored on the data section. So the data section stores a whole bunch of objects, right? So when you write your program, so there are some global variables, there are static variables, there are some constant values. And if you notice all of them, then the common thing about them is that the size of these variables are known before the program runs. And that is why these variables are allocated in a static way. And that allocation happens on the data section. So let me quickly go over what is global variables, static variables, and constant values. For that, let me take an example. So let's understand the data section and the objects that go on the data section with an example, right? So here I have a simple program for you. It's a piece of code that has been written in the C language, right? So what does this code do? It basically computes the area and the perimeter, okay, for a circle. So let us see what are the different data structures, what are the different variables in this piece of code, right? So there is this main function, right? And there is a constant string which is with whose value is a hello string. Then there are four function calls, three calls to the area function and one call to the perimeter function. And there is a variable, global variable pi, whose value is 3.14. It's a value of pi. So as the name suggests, this function calculates the area and area of a circle, and the radius that it uses is a static float variable whose value is initialized to 1.0. So the area is calculated as pi r square, pi into radius. Then it prints the radius and increments, or you can say not increments, it multiplies with the value of 10 to the radius and then returns the area. We'll understand why are we doing all of this. And when you look at the perimeter function, it takes a simple argument, that is the radius r, and it returns the perimeter 2 pi r. So why is this code in this way? Why is it not very simple area and perimeter? So I have written this code in this way so that I can show you what are the different types of variables, what is a global variable, what is a static variable, what are constant values, and all of this will go to the data section, right? So first of all, let's look at the this variable, the variable pi. This is a global variable. So what is a global variable? The global variable is something that you defined outside any function body or a class body, right? So since this is a piece of C code, here we do not have a class. So when you define a variable outside the function body, so here you can see there are three functions: area, perimeter, and main. And outside this function, if you define something, if you declare something, then that variable is a global variable. So pi is a global variable. And why have I made it global? So the crucial property about the global variable is that it can be accessed from any function. So pi will be used to calculate the area. It will also be used to calculate the perimeter. That is why I have defined it globally, so that when we are calculating the area, we can use the pi, right? Similarly, when we are calculating the perimeter, we can use the pi value. So pi is something that we need to access from multiple functions. That is why I have defined it outside the function body, and that is what is a global variable. You define it outside the function body and it is accessible from all the functions. So this is about a global variable. Now let us look at static variables. So what is a static variable? So static variable, the first thing is that you define it with a static keyword. Okay. So here the radius variable, its type is float, and we have made it static. So what is a static variable? The point with the static variable is that first of all, it is only accessible within the function in which it is defined. So static variable, this radius variable, will only be accessible to this area function. The main and the perimeter function cannot access this static variable radius, right? Now, why do you define something as static? So we know that the functions are executed on the stack. And when we call a function, then a stack frame is pushed onto the stack. And when we return from the function, the stack frame is removed. So when this function area is called, then whatever variables, whatever local variables are there inside this function, that is, this area is a local variable, right? This will be destroyed. But if we want some value to persist between function calls, right? Let's say we call the area function here 3 times, and we do not want this value, that is radius, to be destroyed. Then we make it a static. And why will it not be destroyed? Because static variables are placed in the data section. So even if the function is called, when the function returns, the stack frame is removed, right? The data section is not changed. So this radius will go into the data section and it will persist there throughout the execution of the program. So right from the starting of the program till the end, the radius variable will be there in the data section, and we can access this radius variable, this static variable, across multiple function calls, right? So we'll see this through an example. And finally, the constant values. So there are certain values which you define as const keyword, and the string literals, for example, or certain integers or floats, you define it as constant. So these values are not going to be changed once you initialize them. So these variables also go to the data section. So this hello string will also go to the data section. So now that we have a basic idea of what is a global variable, a static variable, and a constant value, now let us see how they are placed in the data section and how they are used. So we'll start executing this code and understand how they are used. So let us start the execution of this piece of code. So here, as you can see, this is the address space, code section, data section, the heap section. We have not yet put anything on the stack. So let's start with the main function. So before that, let us initialize the data section first of all. So when you load your program into the memory, even before the first function, that is the main function, runs, before that you have to initialize the data section. So this will be done by the operating system. So here we have three variables, or you can say objects, that are placed on the data section. The first one is the hello string. So this is a constant value and it will not change throughout the execution. Its size will remain the same. Its value will remain the same. So this is statically allocated on the data section. Then is the radius. So radius is a static variable inside the area function. Again, static variables go into the data section. Finally, the global variable pi, which has been initialized with 3.14. This is also going to the data section. So now we have initialized the data section with all the different objects that should go there, constant values, static variables, and global variables. So now let's start the execution of the program. So let us start with the main function, and you can see this is the stack frame that we have pushed for the main function. Now if you look at the main function, there are 4 printf statements, right? And for every printf statements, there is a function call that will calculate the value which has to be printed for that statement. So we'll have 3 function calls for area and 1 for perimeter. So let's make the first call to the area function, and this is the variable that I have reserved for storing the value which will be returned by the area function. So now we'll go to the area function, we'll make the function call. Now what is being done in the area function? So this is the static variable. Again, one thing that you should know about static variable is that this static variable will be initialized only once, right? You might feel that this initialization will happen every time the function is called, but that is not the case. This initialization will happen only once when the program starts. So the radius variable will be initialized to 1. It won't be reinitialized every time the area function is called, because the initialization happens before the first function call. It happens when the operating system is when the program is being compiled and when the operating system sets up the address space, right? So this statement will not be there in the assembly code that is generated for the function body, right? This initialization has already been done and it will only happen once. So now we enter the area function, and here what we are doing, we have a local variable. So this area variable is local to this area function, and it is storing the area for this radius. So currently the radius is 1. So the area will be 3.14 into 1 into 1, which is 3.14, right? So this is the area that has been calculated. Now we will print the radius, the value of the radius. So the value of radius, which is 1, will be printed to the screen. So this area I will use to show all the output that this program generates. And then we are going to like multiply the value 10 with the radius. So the value of radius will become 10, right? And then we are going to return the area that we calculated, 3.14, to the main function. And when we do that, we also print the area, right? So here if you see, we are using this string, this str hello that we have defined. We are using this string to print the statement, and we are also printing the area which has been calculated. So the constant value, this str that has been defined in the data section, is being used here, right? So you see how all of these variables are being used. The constant value, the static variable, the global variable, all of this are defined on the data section and they are being used, right? Now let's make another function called to the area function. Now you'll understand why have I defined this radius as static, because I want this value to persist across function calls. So initially its value was 1, then I made it 10, and I want to use the value 10, right? Even if the function call has returned this radius variable, since it has been defined on the data section, since it's a static variable, it is still there. And now we can, now when we calculate area, we will use the value of 10 instead of 1. So there might be cases when you want to persist a variable across function calls, right? So let's call the area function again, and this time the radius value that will be used is 10, right? So the area that will be calculated is 3.14 into 10 into 10, right? 3.14 into 100. So the area will be calculated as 314.0. We will again print the radius, which is 10, and return the value of area to the main function. But before that, we also multiply 10 to the radius, and now the radius becomes 100. It was 1. After first function call, it becomes 10. After the second function call, it becomes 100, right? So now we'll return this value 314 to the main function. Again, we will print this statement. We'll use this string hello, and we'll print the area 314.0, right? I'll do this area function call once more, the third time, and you are seeing how the static variable, that is this radius, is being used. With every function call, it is being modified, but it is not being destroyed. Right, from 1 it becomes 10, from 10 it becomes 100, and every time we are using a different value of radius to calculate the area, right? So now let's make the function call to area once again. The area which will be calculated as 3.14 into 100 into 100, which is 31,400.0, right? Then we'll print the value of radius, which is 100, and we will again multiply the value of 10, which, and now the radius will become 1000, right? With every function call, the value of radius is changing and the area that we're calculating is different, right? Now we'll return this area that we calculated to the main function, and then print this statement hello area, right? We are using this constant value, right? So all the function calls to the area function has been done, and you can see the radius is still there. It will only be destroyed after the program terminates. During the program termination, all this contents of data section will be destroyed, right? So now let us make the final function call, which is to the perimeter function, and this is the variable that will store the value returned by the perimeter function. So now let us call the perimeter function with the argument r, and the value of r that we are passing is 5, right? So the value that will be returned is 2 into pi into r, right? So 2 into 5 is 10, and 10 into pi is 31.4. So the perimeter that is calculated as 31.4. This is the value that is returned to the main function. And we also print this statement, that is perimeter with the hello string, right? So the actual value, the precise value is 31.40002, but here just for the sake of simplicity, I have shown 31.4. And when the the main function is about to end, so the main function will also return, and this is the output of the program. And you can see how the data section was used. We stored our constant value, the value which is not changing throughout the program. We store static variables. Static variables and global variables can change, but the size of those variables, the size the size of the memory that they use will not change. So all of these variables are statically allocated on the data section. They persist throughout the execution of the program, right from the starting till the end. And you can see how you can use global variables. If you want something to be accessible from all of the different functions, then you can define it as a global variable. If you want to make something only accessible within a function, but you want that variable to persist across different function calls, then you can make it static, like radius, right? Radius is only accessible in the area function, but it is persisting across multiple calls to the area function, right? So all of this you can do. And so you see how the data section is used. So guys, this was it for this video. In this video we talked about how is the data section used, what are the different objects that go onto the data section, how it is a place for variables which are statically allocated, right? So this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.